continuing on with Lewis dot diagrams. The goals of today are to create Lewis dot diagrams for molecular compounds, identify the central atom, and understand that electrons are being shared. Molecular compounds can also be called molecules, okay? So molecular compounds are formed when electrons are shared. They form a covalent bond. So in ionic compounds, we have ionic bonds. In molecular compounds, we have covalent bonds. So looking at this animation here, we're seeing that there are two hydrogens that are coming together to make H2. Okay, remember the whole diatomic elements, the ones that need to be stable. H2 is one of them because, again, atoms like to have a full valence. So the two hydrogens come together, share the electrons to form H2. So the method that we will be using to create Lewis dot diagrams for molecules is we're going to use a counting method. Okay, so this is how to draw a molecular compound. The first thing that we're going to do is write a chemical formula. So in this example, it says draw a Lewis dot diagram for methane. The chemical formula for methane is CH4. Step 2 is we need to identify the central atom. The central atom is the atom with the most bonding electrons. So comparing the atomic diagrams of carbon and hydrogen, we notice that carbon has 4 bonding electrons and hydrogen only has 1. Therefore, carbon is the central atom because it has the most bonding electrons. Step 3 is we want to count the total number of valence electrons in the molecule. So the chemical formula again for methane is CH4. We have 4 valence electrons in carbon with 1 atom in the molecule. We multiply these two numbers together to get how many valence we have. Same thing for hydrogen. We have 1 valence electron and there are 4 atoms. Multiply those numbers together, we get 4. The total number of valence electrons in this molecule is 8. Therefore, methane has a total of 8 valence electrons. Step 4 is to place electrons around the central atom to complete an octet, duet, or sextet. Most atoms will require an octet. This means that they need 8 electrons around the atom. There are 2 exceptions. Hydrogen will require a duet. Therefore, 2 electrons around the atom. And boron will be stable with a sextet. This means there are 6 electrons around the atom. Okay, so when you are doing the Lewis dot diagram, you're going to put your central atom in the middle. Then, you're going to distribute the rest of the atoms around your central atom. Okay, these are called peripheral atoms. Then you are going to complete the octet and the duet. So we complete the octet on carbon. we complete the duet on hydrogen, okay? So if we notice here, carbon has 8 electrons around them, and hydrogen has 2 electrons around. Notice how these electrons are being shared. Notice how everybody is still happy. You have 8 around carbon and 2 around hydrogen. So behind the scenes, okay, behind the scenes, this is what's happening. Carbon has 4 bonding electrons, and hydrogen comes and brings its electron and bonds with carbon. Okay, so the X's represent the valence electrons of the hydrogen. So this is what's happening behind the scenes. Single bonds are created when 2 electrons are shared between 2 atoms. Okay, so a single bond is when 2 electrons are being shared by 2 atoms. Okay. Okay, so let's do this example. Draw a Lewis dot diagram for the following compounds. Hydrogen gas, the chemical formula for hydrogen gas is H2. Okay? There are 2 atoms of hydrogen with 1 valence each. That's 2 electrons. There is no central atom in this one because there's only 2. So if we were asked for a central atom, we would say no central atom. Okay? The 2 hydrogens bond together. Both of them have their duet complete. The next one we have is nitrogen triiodide. The chemical formula looks like this. Okay, let's count our valence electrons. Nitrogen, there is 1 atom times by 5 valence electrons, 5. Iodine, there is 3 times by 7 valence electrons for a total of 21. Our total valence electrons is equal to 26. Okay, now my central atom, nitrogen or iodine? Nitrogen. So we place nitrogen in the middle. We then place our peripheral atoms around. Complete the octet. Okay, the final thing that we need to do before we complete the octet, before we submit our final answer. First thing you're going to do is count. Make sure there is 26 valence electrons present. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 26. So we're good. The next thing I want you to make sure is that you have 8 valence electrons around everybody who requires an octet. So nitrogen has 8, iodine has 8, 8, and 8. Here we have boron trifluoride. We already have a chemical formula provided, so we do not need to write a chemical formula. Let's calculate our valence. Boron, there is 1 atom of boron, which has 3 valence electrons. Fluorine, there is 3 times by 7 valence electrons for 21, a total of 24 valence electrons. My central atom is going to be what? Boron, okay? Boron is in the center. Fluorine, fluorine, fluorine. Now boron is special. It only needs 6. It requires a sextet. So you're first going to place the electrons where a bond is needed, okay? To not have a lone pair unless you need it. So I place 6 around boron, and then I complete the octet on the fluorines. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24. Okay, so this is my final answer. Okay, so try these two on your own, water and ammonia. Okay, there are the answers for water and ammonia. Bonds. Double bonds. They are created when 4 electrons are shared. For every new bond created, a lone pair will be removed from each involved atom. For example, if oxygen, if we were looking at the Lewis dot diagram of oxygen, we would first count its valence electrons, which it has 12. So going on to the method I showed you, you draw your atoms, and then you complete the octet. Okay, you have your compound, and then we count. 2, 4, 6, 8, 10, 12, 14. We've run into a problem. Okay, we're supposed to have 12, but I have 14. So then we're going to make a double bond. Every time you make a double bond, okay, so I make a double bond, the 2 atoms that are involved, okay, so these 2 atoms that are involved, you're going to remove a lone pair from each. So I erase a lone pair. Oh, I took too many off there. Okay, take a lone pair off there. Hold on, hold on, hold on. Ah! Okay. Put a lone pair back on there. Okay? So now we count. 2, 4, 6, 8, 10, 12. I'm now happy. So with the double bond, your Lewis dot diagram will look like this. Now I have 12 valence electrons. So to recap, this here is to show you behind the scenes of how a double bond is created. You identify that a double bond needs to be created when there are too many valence electrons present. Therefore, a double bond will need to be created. Okay, so the example says draw a Lewis dot diagram for the following compounds. Okay, so you need to identify what type of compound this is. This is a molecular compound because we have nonmetals and nonmetals bonding with each other. First step, write a chemical formula. Second step, calculate total valence electrons. So I have 1 sulfur multiplied by 6 to give me 6. Oxygen, 2 oxygens times by 6, 12 for a total of 18 valence electrons. Now, the central atom for this is going to be sulfur, okay? They all have the same amount of bonding electrons, but we're going to choose sulfur because it's the one that's different from the rest, okay? So sulfur goes in the middle. We place our oxygens around, and then we complete the octet. 2. Okay, then you count. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Too many. So we now need to give a double bond. It doesn't matter who gets the double bond, okay, because they are both the same. So I'm going to give the double bond here, okay, because these two atoms are involved. I am going to take a lone pair off these two. So I'm going to take a lone pair off the oxygen and a lone pair off the sulfur. Now I have 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so this is what my final Lewis dot diagram will look like. Okay, sulfur trioxide. Sulfur. The first thing we're going to do again, calculate our total valence electrons. So 1 sulfur times by 6. Oxygen, 3 times by 6. 18 for a total of 24 electrons. Oh, that looks like a 29. Cancel, cancel. Oh. Okay, so we have 24 total electrons. So again, we're going to start off sulfur in the middle, place our oxygens around, and then complete the octet. Okay, we're now going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6. Okay, we have too many. We have to make a double bond. We make a double bond. The 2 that are involved, we remove. Hold on, hold on. Okay. Okay, let's do that again. Okay, so with the 2 that were involved, we need to remove a lone pair from each. If you do not remove that lone pair, these guys are going to have overloaded valence electrons. Okay, so you need to remove so that they all still have 8. Okay, so if we go back, this oxygen, oh, there's a random speck there. Okay, this oxygen has 2, 4, 6, 8. Okay, so it's not overloaded. Same with the sulfur. It has 2, 4, 6, 8. Okay, you need to be checking that it's not over 8 or under 8. Try these 2 on your own. This one should be different. So we'll make that TeO3. Carbon dioxide, CO2, has a total of 16 valence electrons, okay? I'm going to start with carbon in the middle. Carbon goes in the middle. I spread my oxygens around, and then I complete the octet. Okay, so now I count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Too many. So I make a double bond. I make a double bond here. Both atoms that are involved, I'm going to erase a lone pair off of them. I count 2, 4, 6, 8, 10, 12, 14, 16, 18. Still too many. I have to make another double bond. Okay, so now molecules like to be symmetrical. Okay, so if one side already got a double bond, we're going to give the other side a double bond as well. So now, again, we erase the lone pairs off the 2 atoms involved. We count again. 2, 4, 6, 8, 10, 12, 14, 16. We are happy now. This is what, okay, what not to do. Okay, this is what I do not want you to do. To form a triple bond and have a single bond here. I do not want you to form a triple bond. You only form triple bonds if double bonds are no longer an option. Okay? Okay, so you want to have symmetry. If you can form a double bond, do a double bond first. Do not form a triple bond unless it is absolutely necessary to form a triple bond. Okay, triple bonds. I should obviously say triple. Triple bonds are formed when there are 6 electrons shared between 2 atoms. For every new bond created, a lone pair will be erased or removed from each involved atom. For example, nitrogen has 10 total valence electrons. So if we were to do this, I'm going to show you, this is the behind the scenes. So we have nitrogen. I'm going to complete the octet. And here I have 2, 4, 6, 8, 10, 12, 14 electrons. They have too many. So then I make a double bond and I eliminate 2 lone pairs. So now I have this. Okay, now I have 2, 4, 6, 8, 10, 12. Again, I have too many valence electrons. For this, I cannot make any more double bonds, so I am forced to make a triple bond. So I make a triple bond, and 2 more electron lone pairs are eliminated. My final Lewis dot diagram will look like this. I have 2, 4, 6, 8, 10 valence electrons. Okay, first one. We have a silicon combined with sulfur. You're going to calculate your valence electrons. Silicon, we have 1 atom times by 4 valence electrons. Sulfur, 1 times by 6 equals 6, for a total of 10 electrons. Silicon bonds with sulfur, complete the octet. Okay, I currently have 14 electrons, so I form a double bond. I then erase a lone pair off both. Okay, now I have 12 electrons, so I make a triple bond. And I erase a lone pair off each. Okay, so this is my final answer. We have hydrogen cyanide. Hydrogen cyanide looks like this. Okay? Calculate our total valence. Hydrogen, 1 times 1, 1. Carbon, 1 times 4, 4. Nitrogen, 1 times 5, 5. For a total of 10 electrons. My central atom is carbon. I then place my other atoms around. And then I complete the duet on hydrogen. And the octet on nitrogen. We count 2, 4, 6, 8, 10, 12, 14. Okay, so we have 14. That's too many. So we make a double bond. Can I make a double bond between hydrogen and carbon? No, because hydrogen cannot go past a duet. Okay, so we cannot have it have 4 electrons. So I make a double bond here. I erase. Okay. Now I have 12. Okay, so I need to make another bond. Again, I can't make a double bond between hydrogen and carbon, so I make a triple bond between nitrogen and carbon. Okay? So, if we go back, hydrogen is happy because it has a duet. Carbon is happy because we have 8. And nitrogen is happy because it also has 8.